Hi, my name is Guy Notham, and I am a product specialist at ACIST Medical Systems. I want to introduce to you Rapid FFR. Rapid FFR is done using the RXi and Navvus MicroCatheter. The RXi and Navvus MicroCatheter utilizes a fiber optic transducer for measuring an accurate FFR. The Navvis MicroCatheter is a monorail catheter that allows the interventional cardiologist to use their interventional wire of choice and maintain wire position within the coronary artery throughout the procedure. The Navvis MicroCatheter has an entry profile of just 0.16 inches, and the tapered tip allows for smooth transition through any coronary disease. The fiber optic transducer is positioned just 5 millimeters from the tip of the catheter, which is our competitive advantage. Pressure wires have a transducer set back 30 millimeters back from the tip, which requires much more real estate to get their transducer beyond a coronary stenosis. The Navvis has a 26 centimeter monorail segment, which is similar to most angioplasty balloon systems. The Navvis has two femoral markers, one at 80 and one at 100 centimeters. The working length of the catheter is 150 centimeters, and the total length is 335 centimeters, which gives flexibility to the placement of the RXi system anywhere on the cath lab table. The RXi Console is a simple plug and play when it's mounted bedside with the patient's aortic pressure running through it. Simply plug in the catheter, wait for the light to turn from blue to green, and the Navvis sensor is ready to be placed in the body and equalized. Before I get ahead of myself, let's take a look at the RXi Console itself. The RXi Console has three cables on it. The power cable, which supplies the unit with power. The second cable brings the patient's aortic pressure into the console for FFR calculation. So then we can see the pressure waveforms of the patient on the system. The third cable is actually for exporting the Navvis catheter pressure into the cath lab hemodynamic system. This becomes important when the cath lab hemo system has the FFR software. Across the top of our system is the status bar, and it tells us exactly what step needs to be done next to move on into the FFR procedure. The PA value, this is the mean arterial pressure of the patient. The PD is the mean distal coronary pressure. The PD-PA ratio, often referred to as the resting gradient, is best utilized when equalizing pressures. When equalizing, the PD-PA ratio should be 1, meaning there's a 1-to-1 relationship between the pressures. When recording, the RXi Console will track the pressure gradients, calculate the FFR, and display the value here under FFR. Working around the screen, the record key or the record button records the hyperemic response, then is the zero aortic button. Now the zero aortic button is only used at the time of install. Then we pair or match this system with the hemodynamic system, so you no longer have to zero the system unless you choose to. The next button is the equalize button, followed by the PV button. Now PV allows the user to input a central venous pressure into the FFR calculation. For an accurate FFR, it's important to remove the resistance to blood flow. A high venous pressure increases resistance to blood flow, therefore a PV value should be used in the calculation of FFR. The RXi is the only FFR system in which the PV value can be easily input. On the bottom of the screen is where we see the FFR values. 10 FFR values can be done per vessel, and 10 vessels can be done for a total of 100 FFRs per patient. The case summary is where all the FFRs can be reviewed. In addition, each FFR vessel can be labeled with the appropriate name, either by picking a name from a bank of names, or the user can free text the name using a keyboard.